Let's first look at a video.
おはよう。今日もハッピーな一日となりますように。
This example is actually pretty interesting. It shows a full body view of a beautiful woman in traditional costume, and the face does not take up many pixels in the frame. The video resolution itself is not very high either, only 480 by 832. But if you look closely at the clarity of the face, especially the lip movement, the edges of the facial features, and the overall stability of the character, all of these are quite strong. I think this is the most direct change in LongCat-Video-Avatar 1.5. It is not just simple lip sync or just making the mouth move. The whole image becomes more stable, cleaner, and more like a digital human model that you can actually use for content creation. Now let's look at a few more examples from this model. First, it supports different languages.
When I have a lot to do or I'm overwhelmed, sometimes I struggle with organizing my thoughts and really prioritizing and sticking to one.
おはよう。今日もハッピーな一日となりますように。
经常有人问，喜欢和爱有什么区别？有人说，喜欢是心血来潮，爱是念念不忘；也有人说，喜欢是乍见之欢，爱是永久不厌。
Here we have Chinese, English, and Japanese. You'll notice that its adaptation to multiple languages is pretty good. And it's not only about normal speech. When music and voice are mixed together, it can still maintain relatively natural mouth shapes and expressions. Of course, that does not mean it has no problems. We'll talk about that later. For example, if the motion is not described clearly, it can still look a little conservative. So let me give you the conclusion first. If you used the 1.0 version before, then version 1.5 is not just a small patch or minor update. It has very obvious improvements in image quality, lip sync, stability, and usability for longer videos. Officially, they also mentioned that the audio encoder has been upgraded from Wavy to Vec2 to Whisper. Large. You can simply understand this as the model now having a more detailed understanding of pronunciation rhythm, multilingual cadence, and the mouth shapes corresponding to each phoneme. At the same time, it also uses DMD distillation to compress the generation process down to 8 steps. So while the quality improves, the inference efficiency is also more suitable for real-world use. So here comes the question, can we use this model inside ComfyUI? The answer is of course yes. And today we won't just look at the results. We'll directly break down 3 workflows for you. The first one is called the single workflow. It is suitable for short audio, and one sampling pass can directly produce the result. The second one is called extend. It is suitable for long audio, and you can manually extend the video segment by segment. The third one I call auto extend. It can automatically loop and extend according to the length of the audio. After watching this video, you'll basically know how to use LongCat-Avatar 1.5 inside ComfyUI, and where things are most likely to go wrong. Let's start with the most basic part, installation and model preparation. Here we are still using Kijai's One Video extension. If you have used the 1.0 LongCat Avatar model before, then this step should feel familiar. What we really need to pay attention to here are the model files. There are 2 very important files. One is the main model file, and the second is an acceleration LoRa. Both of these are actually new models. The main audio model has also been switched. We replaced the traditional WAV-R VEXI-R with Whispered and Large VT. Right now, Kijai has not officially released the 1.5 workflow yet, so I will provide 3 versions, the single version, the extend version, and the auto extend version. For easier demonstration, I also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a really great online workflow platform, because whenever new models or new extensions appear, it usually follows up very quickly. Running Hub also provides an online community platform for ComfyUI creators, where you can find a lot of creative inspiration and example workflows, as we just mentioned. Now, let's start with the most basic workflow. What you're seeing now is the single version, which is the simple workflow. Its basic structure can be divided into 6 parts. The first part is model loading here. We load the BF16 main model for LongCat-Avatar 1.5. At the same time, we load an acceleration LoRa. The LoRa weight is set to 1.0 for the scheduler. We use LongCat Distill Euler. Pay attention here. The step count is 8 steps. This is the 8-step distilled model emphasized by the official release. The second part is reference image processing. Here we scale the reference image to 480 by 832. This resolution is not absolutely fixed. You can adjust it based on the aspect ratio of your own image. After the reference image is processed, it goes into OneVideo encode. After this node, it becomes the image embedding used during sampling. You can understand it like this. The reference image is not simply pasted into the video. It becomes a kind of condition that guides the model to maintain the character's identity, composition, and overall visual style. The third part is audio processing, and this is very important. The workflow first uses the trim audio duration node to select the audio segment we need. Then we use the whisper model to encode the audio, and it enters a very important node called LongCat-Avatar Whisper Embeds. This node is actually the most important step in the 1.5 workflow. It converts the audio into audio embeddings that LongCat-Avatar can understand. In a way, this works similarly to text embeddings. The fourth part is the prompt. In the single workflow, I wrote a very simple prompt. Woman is talking happily. The negative prompt is mostly regular quality control, such as blur, overexposure, low quality, and so on. Here, I want to remind you that LongCat-Avatar is still essentially driven by audio to generate video. Its strongest ability is lip sync and digital human expression, not complex action choreography. So if you only write a very simple prompt, like what I wrote here, it will most likely give you a relatively stable and clean talking video. But if you want obvious hand gestures, leaning forward, turning the head, smiling, waving, or even a little handheld camera movement, then you need to clearly write those actions into the prompt. Later, we'll do a dedicated comparison to emphasize how prompts should be written. The fifth part is frame count processing. There is a very important little trap here. The frame count must satisfy the rule of being a multiple of 4 plus 1. For example, 93, 149, and 173 all work. But if you randomly enter a frame count, you may run into errors later during sampling. So in this workflow, I added a special handling step. We first calculate how many frames are needed based on the audio duration, and then use a formula to convert it into a multiple of 4 plus 1. This step looks small, but it is very practical, because the most annoying part of audio-driven video is that the audio length is not fixed. You cannot manually calculate the frame count every time. If the workflow can handle this automatically, it saves a lot of trouble later. The sixth part is sampling and output. After sampling, we decode through the VAE and generate a video. Now let's look at the result from the single workflow. This Japanese example is about 5.96 seconds long, with a total of 149 frames. You can see that the lip sync expression and image stability are already very good. So when your audio is relatively short, for example within 5 seconds, 7 seconds, or 10 seconds, I recommend using the single version and sampling it directly. It is the simplest option and is less likely to run into problems. But in many cases when we make digital human videos, we are not only making 5 or 6 seconds. For example, you may want to make a 15-second talking segment, or even 30 seconds or 1 minute. At that point, one single sampling pass is not very realistic. That is where the extend workflow comes in. The idea is very simple. We first generate the first video segment, then we take part of the ending of that first segment as the reference for the next sampling step. By continuing segment by segment, we can get a longer video. In this workflow, the biggest difference from the single version is that there are two very important sets of parameters, frames and overlap. These also exist in the single workflow, but they are not very important there. You can basically set them however you want. In this extend workflow, I set frames to 93 and overlap to 13. That means each sampling pass generates 93 frames. But when two video segments are stitched together, 13 frames overlap. So what is the purpose of overlap? It is not to make the video longer. It is to create a smoother transition between two segments. Imagine if the first video segment ends directly and the second video segment starts directly. It is very easy to get an obvious jump in the middle. The character's face, hands, hair, or background may suddenly change. So we keep a small overlapping region during the second sampling pass. We use the last 13 frames of the previous video as a reference, allowing the model to continue generating from that state. But there is a very important detail here. During the final stitching, for the overlap part, we directly keep the latter part of the previous segment, instead of keeping the beginning of the next segment. Why? Because although the beginning of the next segment overlaps with the previous one, it is still newly generated by the model. Its quality is often not as stable as the previous segment. So the safer approach is to keep the ending of the previous segment and then attach the next segment after the overlap. In the workflow, we use the image batch extend with overlap node to handle the stitching. Its strategy is set to cut. The advantage of this approach is that it is simple, stable, and less likely to go wrong. Of course, the problem with the extend version is also obvious. It requires manual extension. You need to calculate and judge how much audio is left, and you need to decide whether to run the next segment. For testing, this is fine, but if you want to batch process long videos, it becomes a bit troublesome. So we use the third version called auto extend. The core of auto extend is basically adding a loop on top of the extend workflow. Look here, it adds easy for loop start and easy for loop end. The workflow first calculates the total frame count based on the audio length. Then, based on the frames and overlap, for each sampling pass, it calculates how many loops are needed. The formula used here is seal a funigi. Then -1. If the audio is very short and only needs one sampling pass, then it does not need to enter the loop stage. But if the audio is longer, it will run several more rounds and attach the later parts. So what scenario is auto extend best for? It is best when you have already tested all the parameters and made them stable. And now you want to batch process audio that is 10 plus seconds or even dozens of seconds long. Next, let's talk about a problem that is very easy to overlook: prompts. When many people see an audio-driven digital human model, they instinctively think the audio determines everything. That statement is only half, right? Audio does determine lip sync, speaking rhythm, and part of the expression changes, but the character's main body movement, the size of the motion, whether the camera has a handheld feeling, whether the character leans forward, waves, or smiles, all of these still need to be controlled through prompts. Let's look at two English examples. In the first prompt, the writing is relatively simple, so the character basically just talks steadily. The advantage is that it is clean and less likely to fail. But the downside is also obvious. The overall movement is quite limited. In the second prompt, we describe the actions in much more detail. For example, the character starts with her hand behind her head, then suddenly lowers her hand, the corners of her mouth lift, her body leans closer to the camera, and she makes an open hand gesture. The camera also simulates a slight handheld phone camera shake. When you look at the final result, the motion becomes much richer. This is an important usage trick for version 1.5. If you only want stable lip sync, the prompt can be simple. But if you want the video to be more expressive, you need to write out the actions as much as possible and write them in chronological order. Of course, you must keep the bigger premise in mind. LongCat-Avatar is still mainly a digital human model. So I do not recommend asking the character to dance, spin around, or move quickly. That is not what it is best at. All right, that's all for today. So what are you waiting for? Go try it yourself. Follow me and become someone who truly understands AI.